and welcome to Learn Data. It's great to have you on the channel. I'm Nilesh and today we are going to continue learning about pandas. In this video, you learn how to concatenate or append a data frame, or how to append a series to a data frame, or how to append series together to create a data frame. And we'll look at different scenarios where we append along rows, along columns, and how we can use indexing to make this happen as well. And there will be another part in this particular topic where we'll continue talking about how to merge data frames together. Now let's hop on over to Jupyter Notebook. Here I've already created a new notebook and have the dataset created. So you may have to pause the video to look at what the dataset is. I'll walk you through the dataset right now. As usual, we imported the three libraries: NumPy, Pandas, and Matplotlib. For dataset, there are two parts. One is series and other is DataFrame. Here I've created three series, A, B, and C. The A has elements A1, A2, A3, and I've given that particular series a name SA. The other two series do not have a name. That's on purpose. And for data frames, there are four data frames. This is DF1, which has this has four columns, and the indexes are listed here. They go from 0 to 2. Then we have DF2, which has indices that go from 3 to 5 with the same column names as we saw above here. And if you notice, this particular has the elements that go from M1, M2, M3, and then in the DF2 they go from M4, M5, M6, and DF2, and then for DF3 they go from M7, M8 to M9. So that's on purpose, and it will be clear in just a minute. Also, the indices, they continue, so 0, 1, 2, 3, 4, 5, 6, 7, 8 for DF3. Now for DF4, it's made a little different on purpose. So we still have 4 rows, but then there is no continuation of indices, nor there is any continuation of the numbers inside the elements as well. Okay, so let's get started and talk about how we can append or concatenate data frames together. So very first example, we'll look at a very simple example where let's create few more cells. Okay, so here what we can do first is create a list of the data frames we would like to concatenate. So let's use DF1, DF2, and DF3. So we have this list, and if you look at the list, that's basically the list, all of the data frames put together. Now what we are going to do is concatenate them and put them in a new variable df. So pd.concat, that would be the syntax, open parenthesis, and here we can give the df list, and that would do the concatenation part and give us the new data frame. So as you notice, in this data frame we still have the 4 columns M and OP, which are common in all the 3 data frames that we have used, and this is data from data frame 1, DF1, this is from data frame DF2, and then this part is from data frame DF3. So we have all the 3 data frames in there now. Here what we can do additionally, in addition to the row indices that we see, which are really good, going from 1, 2, 3 up to 8, we can add keys to them. So labels, if you remember the dot lock that we looked at in earlier video, it's the exact same thing that we are going to use here. And to do that, what we want to do is specify that during the concatenation process. So what we are going to do is write pd.concat, and here we'll specify the df list, and now we'll specify the key that let's, what name should we give? Let's give it name m, n, and o. So the idea here is that this particular key m would correspond to the first item in the list, so df1. Then the n would correspond to df2, and similarly df3 it would be o. So when we run this, okay, let's see what's there. Oh, because this has to be keys, not key. Okay, here as you can see, now we have a separate label for each of the data frames data. So m corresponds to df1, here o corresponds to df3. If we want to pull the data set by the label, it's now becomes very easy. We can say df.lock, and here if we specify n, we get the name n is not specified, sorry, it has to be in quotes. So we can see that we were able to easily pull the data that we had appended into the df data frame, or concatenated into the df data frame, which belongs to the data frame df2. So that's the advantage of having the label there. Now let's look at few more other ways we can use the concatenation. Here df is equal to pd.concat. What we are going to do is again use the list, but this time we are going to use the indices that are not similar. So if you remember df4, let's see, our df1 looks like this, and then our df4 looks like this. So here we have the indices that go from 0, 1, 2, and then here the indices are 1, 2, 7. So they are completely different except for the 1 and 2, and then the columns are different too. So the only common columns are m, o, and p. qr is something new in df4 that does not exist in df1. So can we concatenate such two data frames that have different sets of rows and different sets of columns? So the answer is yes, we can. And the way to do that is this way. We again need to specify the data frames that we need to concatenate in a list, and that's what we are doing here. We are putting them in a list, and we will specify the axis. So by saying axis is equal to 1, what we are telling pandas to do is we want them side by side. So here, right here, if we had put 0, they would go at the below the existing rows. So we want them side by side, and here we need to specify sort is equal to false. I'll explain that in a minute. Now when we run this, here as you can see, the new set of data from the df4 is now on the right hand side of the existing data frame df1, and together it creates a new data frame df. The rows that were not in df1 are but they were in df4, such as this one. For df, this part it says nan because those values do not exist, and again these are some values that exist in df1 but didn't exist in the df4, so these are nans here as well. Next, let's look at another topic where we are going to see different types of join conditions. Okay. So if again we use, let's say, join conditions. Now here we'll use df is equal to pd.concat, the same syntax. Again we will use the same data frames df1 and df4, and we'll put the axis as 1. Now in the previous join that we did, we had this is by default an outer join, so join is equal to outer, so we get the same response. What outer does is it puts all the data from both the data frames together. Doesn't matter if the indices match or not. Here these 1 and 2 indices matched, so they are there, but then these 0 and 7 are the indices which are not common in both the data frames. But because it was an outer join, it was a default join, it's put in the final data frame. If we want to avoid that, and if the need is that we only care about those records where the indices of the two data frames match, in that case we can change this outer and put inner. So when we specify inner, only those records that match, so only those indices between the row indices between the two data frames that match, only those are in the final output data frame. And that's what changing the join condition would do. Moreover, we can also play with the indices, so let's look at that. Let's say we create another data frame pd.concat, and here we'll use the same df1 df4, and we'll use the same axis is equal to 1. However, we'll make one change. If we look at this is what we see. Now if we go ahead and change the index of df4, okay, so df4 currently has indices that are 1, 2 and 7. Now here if we apply a reindex condition here, reindex, and if we want the indices of df1 to be applied to df4, this is how we would do it. And then if we run this, now you'll see here that it now has indices from df1 0, 1 and 2, and let's check that. So these are the same indices. However, the data was not there in df4 for the index 0, and therefore those appear as NaNs. Okay, so only 1 and 2 have the data in them. Now if we go ahead and add that condition here, so if we say reindex and we want the indices to be from dx1, and if we run this, here now we have all the indices from df1 in the final output, and only those indices from df4 that exist in df1. Okay, so 7 index number, this row does not exist in df1, and therefore when you applied the reindex condition, that row got dropped. So that's how the reindexing works. We can apply the reindexing in another way. So if you say df is equal to pd.concat, and here if we say df1 for the first one, and instead of waiting until the concatenation is done, we can put the df condition right inside the list. So let's do that. df4.reindex, and this would be df1.index, and outside the list then we can specify axis is equal to 1 and df. So that would work the same way as what we saw earlier. So that's how the reindexing can be used in when we are concatenating a data frame. Now let's switch gears a little bit and look at how we can use the append to bring the two data frames together. And append has some default ways we can use it, so it's easier to use. So but we cannot specify axis in append. As you'll see, it's always axis 0. Now if we want to append, the way we would do it in using append is df is equal to df1 dot append df2, and when we look at df, this is what we get. So it's equivalent to doing this. Df is equal to pd dot concat, and in the list we give df1 df2 and then specify axis is equal to 0 df. So it's the same thing, but instead of doing this, that's kind of the faster way to write the code if it's for sure that it's going to be axis 0. Then here, just if you are curious what would happen if I put axis is equal to 0 there or axis is equal to 1, it's going to throw an error. So the append argument does not support this axis command, so we cannot put axis in there. So it has to be just like that. Now we can also append the df4 data frame the same way, which has mismatch between the columns and the row indices. So the syntax is the same, df1 dot append df4, and let's do df4. So here I made a spelling mistake. Okay, now before looking at the data frame, I just wanted to show this warning. If when you're coding, if you see a warning like this, it's always good idea to read the warning and see what the warning is trying to suggest. Here what the warning is trying to suggest is to accept future behavior, pass sort is equal to false. So this is probably a new change in the Python, and to avoid that warning to show up, we can add that particular line and then the warning would not appear. Here, as we can see, the df4 was appended and the axis was 0, and therefore we appended the df4 below the df1. And since the columns O and P were common in both df1 and df4, therefore they appear right here. So the data appears right in the same columns. However, the NaNs appear in the columns where there is a mismatch. So the columns M and N do not appear in df1. So if you look at df1, they do not appear in df4. And if we look at df4, so there is no M and N column there. So that's why these are NaNs for these three rows that are coming from df1. Similarly, QR is not there. This stops at P. There is no QR in df1, and therefore the top three rows have NaNs for the columns Q and R. Next, let's look at how we can append more than one data frame using the append statement. And to do that, again, you probably guessed it, we have to specify those in the list. So df2 df3, and when we run this, okay, let's put df3. This is how we would get the appended data frame using multiple data frames. Now beyond this, there is another parameter that we can specify during concatenation and both append processes, and that is ignore index. What ignore index does is it gives us an option to either ignore or consider the index from the two joining data frames, and I will show that in just a minute. Let's say if we are trying to concatenate data frames df1 and df4 again. So df is equal to pd dot concat df1 df4, and we'll try to do the join without ignore index command first, just so that we know what the difference looks like. And when we run this is the output we get. Here we can copy this, paste it here. Now specify ignore underscore index is equal to true. So what ignore index is equal to true means is that for the incoming data frame, which is the df4, do we want to go ahead and ignore the index that is 1, 2 and 7 for this data frame? And if you do that, as you can see here, what Pandas is doing is it is now continuing from the index from df1. So df1 is 0, 1, 2, so it continues that index line consecutively to 3, 4, 5 for the df4 that is getting attached to df1. Okay, now instead of true, had we set it to false, the original index stays for df4, the 1, 2 and 7 stays for df4. Okay, so ignoring index, if we say yes, then it means that we don't care about the index of the incoming data frame. And these are, we'll see some use cases of this and it will become more clear why this is needed. Similarly, let's look at how we can use ignore index in case of append. So if we say df1.append df4 ignore underscore index is equal to true, and here we say sort is equal to false, and then say df. Again, as you expect, the indices for df4 data frame that got appended below df1 has now 3, 4, 5 as indices for the rows, which earlier were 1, 2 and 7. Okay, and now let's move on to another area in this where we can append series plus data frame, or series plus series, either one, or series plus series. Can we do that, and how we can do that? We already have created 3 series A, B and C, so we'll just go ahead and use those. If we were to create a data frame df1 and we use concat, now we can append the series A to the data frame df1. A series A looks like this, which has 3 elements, A1, A2, A3. It has a name SA, and our df1 looks like this, which has 4 columns and 3 rows, and these are the elements within those. So it would be df. Again, we have to specify them in a list as we have done before, and the axis is equal to 1. What that would do is we are going to put this new series A right on the right side of column P. So it would be a vertical column that should be created. And as you can see that we now have the series SA, which is the series A with name SA, added here on the right hand side, which is A1, A2, A3. Similar to this, we can also go ahead and append series which does not have a name. Okay, so instead of this, let's go ahead copy. If you look at the series B, the series B does not have a name, it just says data type object, and that's about it. So what we can do is we can go ahead and append series B, and what you'll see is that the column name is given as 0 because there is no name, and therefore Python has chosen to give it a column name as 0. So that's what would happen if the series does not have a name already. Now you're probably wondering, what if we append the series together? There's no need of data. Can we append A to B to C and create 3 columns, and that 3 columns could be a data frame? And that's, yes, that is possible. So let's try that. df is equal to pd.concat, and here again we have to specify it, the series is in a list, and we can specify axis is equal to 1 and df. So here as you can see we have the three series A, B and C now as columns of the data frame df. The column names are SA 0 and 1. The SA is because we had provided the name for the series A upfront, therefore that name is now used as a column name. However, for B and C there is no column name, so those were generated and those are 0 and 1. Here we can go a step further and we can specify new column names if we want to, and to do that, just as we had put keys earlier for the lock in DataFrame, we can do the same here for the column names. So we can specify keys is equal to, let's say this could be alpha, and this could be beta, and this could be maybe comma. And when we run this, we now have the data frame with the three series put together as columns, and they also have corresponding column names. That was it for this video. We'll continue this discussion in next video, where we'll talk about merging and other ways where how we can join the data frames. I hope you learned something new today. This is a really important topic, and please like, share and subscribe. I'll see you all in the next video. Thank you.